So we learned hypothesis testing with one sample. Now we are going to do hypothesis testing with two samples. What does that mean? We are going to compare these two samples. When you compare two samples, you can compare them by mean, by proportion, and by deviation, variance. So we are going to focus on mean here. So we are going to test the difference between means, large independent samples, and testing the difference between mean, small independent samples. To understand what means dependent and independent, if we are talking, let's say, comparing a group of guys and group of sport women, they are independent. They don't have anything in common. So these two samples are going to be independent. But if I take, let's say, a group of women, for example, and try, let's say, figure out their favorite food, for example, before 40 years old, let's say, and then after 40 years old, try to see if their taste is changing, if they like different things after 40 years old. Those are dependable data because we are testing the same people, right? And there are some biological, some genes and habits and everything, it's gonna affect somehow, correct? So those are going to be dependable samples. So we're going to work with independent samples right now. So testing the difference between means, large independent samples. Okay, we know that samples can be large, and the cornerstone, the sample size is 30. So above 30, the sample considered large one. So what we are going to do here, objectives. Determine whether two samples are independent or dependent, and then perform a two-sample z-test for the difference between two means, mu1 and mu2, using large independent samples. So like I said, comparing two samples, hypothesis test, that is comparing two parameters from two populations. So we're comparing samples and we're applying to population, as you remember. So sampling method, we are going to use either the independent sample, or we are going to use dependent samples. Which one is what, we already know, right? Independent, these two samples depend on each other. Independent, they don't depend on each other. But dependable ones, they are kind of paired or matched, okay? Those are dependent samples. We're going to work with independent. So here is just visually showing independent. This is independent one, which is going to be our focus. Okay, so example for independent and dependent samples. So classify the pair of samples as independent or dependent. So first one, it says weight of 65 college students before their freshman years begin. Sample 2, weight of the same 65 college students after their freshman year. Obviously, this is going to be dependent samples because we are using same 65 college students, right? Okay. Example, independent and dependent samples, another one. So we have sample 1 is a score for 38 adult males on a psychological screening test for attention deficit hyperactivity disorder. And sample 2 scores for 50 adult female. That's already telling me that it's independent because here it says adult male and here it says adult female, and I don't even continue reading because 38 male and 50 females, they are not related to each other anyhow. So those are independent samples. Next one. Two sample hypothesis test with independent samples. So we're starting basically two sample ones with independent samples. So null hypothesis, it's our statistical hypothesis that usually states, we already know, equal sign, greater, equal, less, equal. And alternative is the rest, greater, less, not equal, which means everything that has doesn't have equal sign. Okay. Two sample hypothesis test with independent samples. So how we are checking if they are equal or not equal? We make this hypothesis test. Mu1 is equal mu2. Okay, mu1 is equal mu2 everywhere. Here it is. We're also checking is equal. So sometimes they can write down greater, equal, or sometimes they just put equal. As long as equal there, equal sign is in there, that means it's a null hypothesis. And complement is going to be alternative. So very important note here. Regardless of which hypothesis you use, you always assume there is no difference, just like in the case of one sample, we're testing the claim. We always start with equal sign. We assume it is true, and we test the equal sign. The same way here, equal sign, but in this case, we accept that the means are equal. All right. Two sample z-test for difference between means. Because we are dealing with large samples, then we are going to use z-test. Yes? So 3 conditions are necessary to perform z-test for difference between two population mean. Sample must be randomly selected. That's the basic requirement that we already all know. So it has to be randomly selected for hypothesis test. Samples must be independent because we are testing independent samples. But there is also, when we start testing dependent samples, then our requirement will be dependency also. So each sample size must be at least 30. Remember when I said the 30 and above, we're going to consider large sample. Or if not, each population must have normal distribution with known standard deviation. Okay. So either sample size, so conditions, very important. So either sample size has to be greater or equal 30, or standard deviation, sigma, is known. Okay, these two conditions have to be. All right. If let's say sample size is not 30, but sigma, standard deviation of the population, is known, because standard deviation for the sample is S, remember? This is for population. This is for sample S. Okay. If standard deviation of population is known, then we don't care sample size. So we are going to use z-test. All right. Next. Two sample z-test for the difference between means. Well, let's start doing. If these requirements are met, then the sampling distribution for x1 minus x2, difference between the sample means, is normal distribution. Okay, so what do? We are going to test. First, we assume that we believe, and we take the fact that mu1 is equal mu2. How do we do that? Mu1 minus mu2, we need to get 0. That means they are equal, yes? All right. So therefore, we are going to test, since our test is going to work with sample and draw conclusion about population mean, which is in this case of mu1, sample average is going to be x1, and sample average for mu2, it's going to be x2. And sigma, this is our standard error formula. Sigma is our standard deviation of the population, which is also we call a standard error. So sampling distribution, this is how we look. This is our mu1 minus mu2, and it equals 0, because average is also, if we have normal distribution, the average is z-score is always equals 0. Now, and then we have sigma standard deviation x1 minus x2, x1 minus x2. So let's move on with solving such problem. Okay, so two sample z-test for difference between mean. Test statistics. Before we would do test statistics for only one sample. Now we are going to do for two samples, which is going to be x1 minus x2, and standardized test statistics, standardized z-score, just exactly like in one sample hypothesis test, with the difference. Remember, for one sample we would have z standardized equal x minus mu over sigma. If sample size we know, then we divide by square root of n. So instead of x, now we take difference now, because we have two samples. So difference between sample x, mean, minus difference between population mean, and divide by standard deviation of the difference between sample mean. When I say difference between sample mean, that's mean average of the one sample minus average of the other sample, and we need to keep the same sequence for the population also. The mu for the first population minus mu for the second one. You can't do x1 minus x2 for sample and do mu2 minus mu1 for the second for the population. It's not going to happen. If you're starting with index 1 minus index 2, it doesn't matter which one you start. You can put x2 minus x1, but that's mean mu2 has to be also minus mu1. You need to keep the index. If you take first sample minus second, then you have to do first population minus second population. Okay? And the formula for sigma standard deviation for the difference between populations is here standard deviation for first population, standard deviation for second population, and sample size for both of them. So when the samples are large, you can use S1 and S2 in place of S1, sigma 1, sigma 2. What does it mean? When, let's say, a sample size is given, and we know it's greater or equal 30, but sigma is not given, then we can replace sigma with S1 and S2. Are we clear? This is, we use this formula we use when sigma is known, meaning standard deviation of the population is known. You can take the notes about this, is important stuff. But if sample size is greater than 30, equal or greater 30, and sigma is not known, then we use the substitute, which is going to be sample standard deviation, S1 and S2. Okay. So, this is all only just summarizing everything no, I haven't said this. Okay, let me go over. So how we gonna solve it? Steps. So first we need to claim mathematically the hypothesis test, which is difference between two means. Okay, and then we need to know alpha level. Obviously, it's going to be given. Find the critical value from the z-score table and determine rejection area. Okay, let's get going. So finding, okay, here is going all the way to the all details. So 1 second. So for independent samples, this is the formula for standardized test statistics. Okay. Although I'm going to use it and write down so many times, but you can write down this formula. And withdraw decision. So if z-score in rejection area, we reject null hypothesis. If it's in fail to reject area, then we fail to reject and draw interpretation. All right. So here is our problem. Example. Two sample z-tests for difference between means. A credit card watchdog. Okay, let me get color. A credit card watchdog group claims that there is difference in the mean credit card debts of household in New York and Texas. So here we have New York and Texas, okay? The result of random survey of 250 households, that right away should click in your mind, that's a sample size, okay? And one from each state meaning the Texas also, they took 250 sample size. Do the result support the group's claim? Do these results support the group's claim? Here the data, X bar, S, and alpha is 0.05. Okay. All right. So what do we have? Here is our claim, hypothesis test. Null hypothesis we put always equal, right? Let me see. Since how do we know which tail it is? What do we have? Difference in the mean credit card debt household in New York, that there is a difference, okay? The result, so they say there is a difference, meaning there is a difference, which means mu1 does not equal mu2, right? Which means we are dealing with two tail, and this is going to be our claim. I here underlined with blue color. Okay. So therefore, our alternative, this is going to be our claim, it's overlapped here. So let me choose bright color here, is blue, all right? And this is our claim. And null hypothesis accordingly is going to be mu1 is equal mu2. Alpha is 0.05, you can see here. although the words overlapping, I can't separate them now. Overlapping, but alpha we have, or I can write down 0.05, and sample size is the same. Okay, so we need to see if we reject the null hypothesis or we fail to reject. So z-score, remember what we said? It's going to be this z standardized. This is our z standardized, right? So we are getting 4,446.25. Let me show you where from it is. Here it is. Write down this information. X1 is 4,446.25, X2 4,567.24, and standard deviation 10457 and 1361.95. Okay, so we need to the z-score standardize says keep running. Okay, says that z standardized, this is our x1 minus x2. This 0 is mu1 minus mu2. Now, why is it 0? Because we always assume, we trust but verify. So we trust that mu1 is equal mu2. Therefore, when you subtract, it's going to be 0, right? And we divide by the sigma x. That is going to be the standard deviation for the difference of two samples. And I'll put a link to the calculator to figure out the sigma easily. And z standard and z the score we get here negative 1.11. Now, how we are going to figure out if we are failing to reject or we are rejecting our null hypothesis. So this is our z standardized. So here we are going to use z critical, which means since we have two-tail test, we take this our alpha, right, for two-tail. It's going to be splitted by 2, right? Alpha half we need to take. Which means here it's going to be 0, this area is going to be 0.025. And this area also going to be 0.025, right? So we are going to, again, z-score table. And obviously we are going to negative z-score table because in negative z-score table, this probability inside is between 0% to 50%. This is for negative. And in positive z-score table, probability provided is 50% all the way to, well, theoretically 100%, but realistically, statistics never gives you anything 100%, so it's going to be 99.99 something. All right, and because we have 0.025, which is 2.5%, we are going straight to negative z-score. And if you look it up, you are going, since our z-score table shows left tail, that's mean it's going to be left tail. This is our mean, right, 0. So this is mean negative, this is positive. It's going to be negative sign. And here I see it showing negative 1.96 you should get. And for right tail, you are flipping the sign and get positive 1.96 because they are equal, it's just signs are different. So if this is our negative plus minus, negative 1.96, positive 1.96, forgive me, it's a rough drafting, and our z critical is negative 1.11, so it's falling in healthy area, right? Let me see. This is our healthy area, fail to reject area. Therefore, we failed at 5% level, it's alpha 0.05 of significance level. What do? We fail to reject null hypothesis, right? If we fail to reject null hypothesis, then complement is going to be alternative, so which means we reject alternative. Why we are interested in alternative? Because alternative is the one that is our claim. So which means we are going to draw conclusion, make interpretation regarding the hypothesis test, hypothesis alpha, alternative. Okay, so we need to using the verbiage support, right? Because alternative using verbiage support, and null is using verbiage reject. So using the verbiage support, we're gonna build the sentence that will mean that we reject null hypothesis, alternative hypothesis. So how we gonna build here? It clearly says that at 5% significance level, there is not enough evidence to support, which means indirectly we are implying that we reject it. Alternative hypothesis. All right? Okay. It's kind of similar, very similar to the one sample test, hypothesis test. All right. Now, next one, now we're going to deal with different sample size. It's the same thing and different sample size. It just alpha is going to be 0.01. All right, let's get going. If there is enough evidence to support the claim. What claim it says? A travel agency claimed that average daily cost of meals and lodging for vacationing in Texas is okay. Now, claim says mu1, or I would rather put mu Texas, because Texas is claiming less than, so we can put mu Texas is less than mu Virginia, right? Mu Virginia. That's what they claim. And at alpha 0.01. Wow. Pretty low error, 0.01. Interesting. Okay, so they are pretty confident that the average daily cost of meal and lodging for vacationing in Texas is less than in Virginia. Well, you can remember that. And you will know that in Texas it's cheaper to go than to Virginia. Okay, so this solution is represented by using technology. So here we have result. This is with green marker, I already marked. So when I was going over, so this is our standardized test statistics. Okay, standardized. Test statistics, z is equal negative 1.25. P-value is given. So you can either, what we can do, we can either, oh, it's thick already enough. Okay, we either can, to draw conclusion, we can either p-value compare to alpha 0.01, or we take this our z-score, z standardized test statistics, compare to z critical, either or, right? Since we have left tail, let's see, we have left tail, and our alpha is 0.01, and our p-value is 0.1, which is falling into fail to reject area, right? Well, let's compare now, see if we get the same thing with comparing to standardized z-score to z-critical. There we go. And it's confirming. Z comparison also gives us same thing. So Z critical negative 233, that we are getting based on alpha 0.01, obviously, because you are going to Z-score table, and the match is for Z-score 01 alpha, it's going to be negative 2.33. And since our standardized Z-score is negative 1.25, it's falling in fail to reject area. Okay, so our null hypothesis is fail to reject. Now we are heading towards drawing conclusion. Our subject of interest, which is our claim, then it's going to be alternative is rejecting. Right? Rejecting. So rejecting the claim. So from here, we know that the verbiage we use with our alternative hypothesis is support. The verbiage we use for to draw conclusion for null hypothesis is reject. So we want to deliver the meaning that we reject alternative hypothesis using the verbiage support. How are we going to do it? We're going to say not enough or not sufficient evidence to support. So practically we are implying that we are rejecting. And we are doing this at 1% significance level. We reject, there is not enough evidence to support the travel agency's claim, which means that Texas has greater or at least equal expenses as comparing to Virginia. Okay. Moving to next one. All right, so this is summarizing. You can read it. We already covered it. Just you can read it. I'm moving to next one. Now we are going to test the difference between means for small independent sample sizes, which means we are going to use t-score and sample size is going to be less than 30. So we're going to perform t-test for difference between two population means using small independent sample. Okay. So those are here important information. So if sample size of samples of size less than 30 are taken from normally distributed population, a t-test may be conducted to test the difference between the population mean mu1 and mu2. Okay. Three conditions. So again, it has to be randomly. Again, it has to be independent. Again, it has to be normal distribution. Formulas. Test statistics is x. Hold on. Test statistics x1 minus x2. Okay, I picked up shading. I meant to pick this. X1 minus x2. And standardized test statistics, this one is very important because that's one we're going to calculate. And I will find some online calculator for difference, standard deviation for the difference of two samples. Okay, and that's what we call standard error, obviously. Okay, the standard error and the degree of freedom of the sampling distribution depends on whether the population variances sigma 1 squared and sigma 2 squared are equal. So we are going to look into these cases. So we are going to look into cases when variances are equal and variances are not equal. Information from the sample is combined to calculate a pooled estimate. When variances are equal, we are going to use the following formula. Variances are equal, which means sigma 1 squared is equal sigma 2 squared. Sigma itself is a standard deviation. You square it, it becomes variance. So sigma 1 squared is equal sigma 2 squared. Second one, standard error for sampling distribution, where sigma 1 is not equal to sigma 2. That's when we use this formula, and we are going to use n1 plus n2 minus 2. Why do we do n1 plus n2 minus 2? Because we use n1 minus 1, degree free of freedom, and then we use n2 minus 1, degree of freedom. You get n1 plus n2 and minus 2, right? Okay. So, variances are not equal. This is going to be your formula. Write down this formula for standard deviation when variances are not equal. And between degree of freedom, we are going to take whichever is smaller. So, for the case, let's do it. Variances are not equal. Sigma 1 squared is not equal sigma 2 squared. This is the case. So this is how we're going to calculate variance for the standard deviation for the sample. This is the formula. Now don't be scared of these formulas. I will see if I can find some online calculator, so these elements will be solved for you real quick. You just take result and focus on the test, okay? Now, since we are going to use degree of freedom and variances are not equal, so how you going to figure out which one you're going to use it? So you're going to use, take first one, the f, which is equal n1 minus 1, and the f2, which is equal n2 minus 1 also, and we take whichever is smaller one. You're going to take only one only, but whichever will be smaller. Whichever is smaller, that's the degree of freedom you are taking. Okay? All right. Please don't focus on formula. I will come up with some ideas, so you don't have to do some details there of calculation. Okay. So this is it's just a diagram how to figure out, because the word problem, when it's giving you, it doesn't tell you use the z-score or use a t-score. You are the one who will figure out, and here is summarizing the diagram what to use, z-score or t-score. So we start with sample size. Is it 30 or more? Is it 30 or more? Yes. If it's yes, we are using z-test. There is no question about that. If it's not, then we are digging further. It doesn't automatically mean that we are going to use t-score. No. We are going to check, okay, it's not greater than 30. But what we are going to check here is sigma known. Sigma is known. Population standard deviation. If yes, known. Normally this says no, it's not yes. Okay, I'm sorry. Never mind, I was joking. Let me write where yes is. Are they normally distributed? Well, we're assuming it's going to be, in our case, all of them are going to be, word problems are going to be normally distributed. If not, If it's not normally distributed, you cannot, and here we arrived, you cannot use neither, I wanted to use red color. We cannot use, okay, it's some ugly color. So we cannot use z-score or t-score if it's not normal distribution. So look for the word normally distributed because that will guide you. But if it's normally distributed, which is going to be 99.9% our case in these problems, then next we are going to look for if the population population standard deviation is known. If it's known, again, I got ahead too much. I should put here. If it's known, sigma, standard deviation variance is known, but sample size is less than 30, doesn't matter. But as long as sigma is known, we are using z-score. So here is conclusion. Look at for sigma. If sigma is given, then that's it. Forget about, you don't even care. Sample size, what size it is. So we are using z-score, period. That's going to be our approach. But if sigma is not known, then we are looking at the sample size. If sample size is less, okay, then we are heading towards t-score test. How we are going to do? Now we need to know other problem get up in front of us if sample size is small. If standard deviation is not known, then we are checking the variance. Variance can be if standard deviation is not known, then we're gonna find out from the word problem if variance is equal or not equal. If it's equal, we are going to use these formulas. Okay, if it's not equal, then we are going to use these formulas. All right? Okay. So here is telling step by step what you're going to do. You can read this yourself because this step by step I'm going to solve anyway. So I'm going to cover all the steps. All right. Determine, okay, this is still continuing. You can read it. I rather move to solving. So here we have example, two sample t-test for the difference between means. All right, let's see. What do we have? The result of state mathematics test for random samples of students taught by two different teachers at the same school are shown below. So what do we have below? We know that sigma is unknown. Right there, right away. Sigma is unknown, right? Then in that case, we are looking at sample size. Sample size is less than 20. Okay, that means we are going to apply t-score test, t-test. Now we need to look if variance is equal or not equal. Alpha, let me also write down, alpha is 0.01. All right. So, two sample t-test for the difference between means. What was our claim? I missed it. The result of state mathematics randomly taught by two different teachers at the same school. Can you conclude that there is difference between in the mean? Okay, difference. To tell, and this is a claim. To tell with the claim that it's not equal. Okay, so This is going to be our claim. Mu1 is not equal mu2, and this is our alpha, 0.1. So then we need to find standardized test t score, standardized t-test. This is your x1 minus x2, right? And this is mu1 minus mu2. This is our square. This is s x1 minus x2, which is, remember, s1 squared over n1 plus s2 squared over n2. I'll see if I can find some weight so you won't have to calculate this by hand anymore. So we'll see. I'll figure out something, and I check the link under this video, okay, in the comments. So the bottom line is, let's focus on solution. So t statistic, standardized test is equal 0.922, and our t critical is negative. Here it is, negative 1.895. I'll tell you in a minute how we got it. Positive 1.895. Remember, we get t critical based on alpha, that is equal 0.1, and based on degree of freedom. The degree of freedom, since we have two degree of freedoms, two sample size, one is 8, here it is, and one is 18. Remember what I said, you choose the smallest one, smaller sample size, and which means the degree of freedom will be 8 minus 1, 7. So in t-score table, you look for two-tail, right? Alpha for two-tail, 0.1. This is going to be your alpha here. And down here, it's going to be your degree of freedom. You have in this table, you have two choices. Either can go back to assignment when you had t-score 1 sample, there is a t-score table is given, open that one, or just search on internet t-score. I would recommend to go back and use that one because there are a bunch of other t-score tables so you won't get confused and use cumulative or other stuff. Just have it opened or take a picture of your t-score table from your last assignment, and that will take care of it. So, and as a result, T critical should be plus minus 1.895, and our standardized test is 0.922, which is falling in this area, which means we fail to reject null hypothesis. What's happening in all three problems we solve? We all reject null hypothesis, which means we reject alternative, our claim. We reject our claim. And with the verbiage support, we say at 10% level, because 0.1 of significance, there is not enough evidence to support, because we have alternative hypothesis, our claim. We use the verbiage support the claim that mean mathematics test scores for the student of the two teachers are different. Okay. So this is, they are solving one more. So what do we have here? 14 sample size. 14, 18, sample size is different. We are given again, S, that means sigma is unknown. So practically we are given standard deviation of population, of simple, and population is not given, right? And accordingly we are going to solve, pick up the formula that match to this given data. And let's not to forget alpha is equal 0.05. All right, let's start solving. We need to figure out the claim that the phone is greater than, from one company is greater than the other one. So we are going to test mu1 is greater than mu2. It's alternative claim. I also would like to bring your attention to the fact that population variance is the same, equal. Previous problem we were solving, there wasn't written variance is equal, but instead, so we calculated, we took the degree of freedom for less sample, right? And we built the standardized test. Now we have variance equal. So what does that tell us? That tells us that our degree of freedom is going to be calculated as a sum of n1, n2, here n1 plus this is n2 and minus 2. And that will give us a degree of freedom. Here we have 1.7 is calculated T critical, 1.701. Since we have right tail, so let's see, in the T-score table, you should find alpha, right tail, and degree of freedom, you should find 28, and that should give you 1.701, okay? So, now we need our standardized T, right? Test. So we can compare with critical value 1.7. So this is, we solve, use this formula when we have our variances same. Now, no panicking. I will find some calculation or some method, some way to have it solve it for you, make it easy. Okay, this is deviation, and this is our standardized test. So now what we have to do, we are going to compare 1.811. This is our t-test, right? I mean standardized test, right? 1.811. And our critical value 1.701. There we go. So since 1.811 is falling in the area of error, then we reject. Hallelujah. Finally, in one case, we reject null hypothesis. Okay, we reject null hypothesis. Our claim is alternative, right? So if we reject null hypothesis, that means fail to reject alternative hypothesis. So conclusion we draw. If we fail to reject a null alternative hypothesis, that means with using the verbiage support, we're gonna say that we accept it alternative, and we say that there is enough evidence to support the manufacturer's claim and blah blah blah. You already know. You can read it. Okay. So I am done. So we learned to do test for two samples with the mean, where we have independent samples, and the case where variances are equal or variances are not equal. So now I will go over problems. All right, I would highly recommend to watch this lecture first before you take your do your assignment. Okay.